Hello, and let's take a look at your MT12 LT5 seminar on probability with multiplication. Most of what we're going to be doing today is going to be doing with multiplication. Before I forget, do the first 5 questions. We'll go over those 6 questions. We'll go over those in class. Work ahead, get them done so you can, when I call on you, you can do them. And if you want to wait till we do in class, that's fine with me too. A compound event is where we have two different things going on. An independent event is where what happens the first time has no effect on the second time. I gave an example of a spinner. What I get on the first spin has no bearing on what we get on the second spin. And we did a problem like that in the previous lesson where we talked about Elena and I'm trying to remember the two singers. Those were independent events. Well, actually, they're dependent events. We'll talk about them in a second. But when I want to find the probability of two independent events, I just multiply the two probabilities together. There's nothing big about that. You probably did that in middle school, but it's also been a while, so that's what we're going to do. So if we take a look here, Sarah's a member of a gaming website that randomly pairs users together to solve problems. Of the 50 players currently online, Sarah is friends with 10 of them. Suppose Sarah is paired with a player for a game. Not liking the outcome, she disconnects and is paired again. What's the probability that Sarah is not paired with a friend each match? Now they're independent because when she stops the game, she picks a new friend from the same group. So the probability of not being a friend, since she has 10 friends, would be 40 out of 50. So the probability that she gets 2 not friends we're just going to multiply those together. It'd be 40 out of 50 times 40 out of 50, which is the same thing as 40 out of 50 squared. And then we can reduce that to 4/5 squared. And that would be 16 out of 25. That's not a bad fraction to work with. We could say 16 out of 25, that's understandable. But you could also write it as a decimal. And 16 divided by 25 is 0.64, or 64%. Now, contrast that with dependent events. That's where I gave the example yesterday of Elena and Ruby singing. Elena sings, and then Ruby goes second. So what happens to Elena affects what happens to Ruby. In this case that I gave you on your seminar, we're drawing balls out of a bag. Well, if I don't put it back in, that changes the outcome. So they're dependent events. So let's take a look here. Which of these are independent and dependent? We talked about spinning a spinner twice. That's going to be independent. Now, in a raffle, one ticket is drawn for first place, then another ticket is drawn for second place. Well, we're going to assume you can't win first and second. So we're going to say if you win first place, your name is taken out of the hat. Well, if your name is taken out, you just change the sample space. So that those are dependent.